So let's go. All right, first thing, why did I decide to start with this lecture? So when you start a new project, and usually when you start your developer journey on DIC, you will usually run the dfx new command, and you will get this template project. And I remember that when I started, it was very confusing. Why do we need so many files? What are all those files related to? And how those files connected? All sorts of questions. So in this lecture, I will try to explain the role of each file, which files you need to focus on for this specific bootcamp, and how all of them are connected and how you can learn more if you're interested. So this is going to be very beginner friendly. If you are like experienced web developer, you might not get as much from this lecture, but I still advise you to stay around, especially for the Motoko side of things. So before we create the first template project, we need to run some verification. So the first one would be to verify that we have the fx installed with this command, the fx version. Of course, you can get a different version, but I recommend to upgrade to the latest version if you can. And the second thing is to verify that we have Node installed, and also you can have a different version. This one is probably a bit outdated, but it should be fine. If you don't have Node installed, it's only going to spin up certain files and you will miss out on the front-end parts. So you might have a project, but a project that will be different than mine. And so don't get confused by that. All right, so now we are good to go. So I'm gonna move into a folder. So I'm gonna move into project/Motoko Bootcamp, but you can also do it from your main folder. And then I'm gonna run the dfx new command with the name of the first project that I'm just gonna call first project. So as you can see, it's creating a lot of different files, installing Node dependencies as well. We have the main.mo file, some JavaScript file, some text file, some images, those are SVG. We have CSS file, JSON, and also an icon. So a lot of different files, as you can see. We have the beautiful Internet Computer logo, and now it's done. So we also have some link to like useful resources. Now we're going to move into first projects and open VS Code with this command. If this command doesn't work, it's because you need to set it up. You can also just open VS Code manually. Okay, one very important thing to understand is that we have a lot of different files, but we need to stay focused on what really matters. And what really matters in our case is the source folder, because this is where you will find the code for the canisters. And in this folder, you will find the backends. So this is going to be Motoko. And this is what we're going to focus most of our attention during the week. But you also have this front-end canister, which is written in JavaScript, HTML, and CSS. And that's also an important part of being a developer on DIC. I wanted to show you this picture because I want to make very clear what is the front-end and what is the backend. So the front-end is actually a web page that you can access from your browser directly. So if you go to the canister ID, you will find that on your browser. So 100% on chain, and you can enter your name. That is the front end. This is written in JavaScript, HTML, and CSS. And that's what we've seen. And the backend, you cannot really directly access the backend because you cannot see it. There is something called the Candid UI, which is a way to see the interface. And the backend canister is written in Motoko. And there is one public function which is great, at least for this template project. One thing to understand is that whether it's written in JavaScript or in Motoko, in the end, it's a canister, so it's a WebAssembly module inside. We can divide the files into two categories. The first one are the files specific to the Internet Computer, and the second one are the files that are more generic to web development. The first category would include dfx.json and main.mo. If you have a question or you want to know more about those files, you can find information on the Definity forum, on the ICP community Discord, on internetcomputer.org, or you can just ask other devs or at the Motoko Bootcamp. If you have questions related to other files, you will usually find the answer either asking ChatGPT. You can also find videos on YouTube. You can buy courses on Udemy, or you can just ask on Stack Overflow. All right, so I know I said that we should focus on the Motoko side of things, but if you are like me, you will probably be a bit curious to know what are the role of those other files. So let's go quickly through them. Let's start with the README. The README is actually very important because it's the documentation for your project. If you are working with another developer, this is the first thing that this person will check to try to understand what your project is about and how he can use this project. The README is written with a special syntax, which is the markdown. That's why the .md. So don't neglect the README. You might not need to write it right now if you are just starting your career, but this is very important to read the README of other developers to understand how to explain a project, how to start a project, and especially in Web3, where you need to collaborate with other people and you need to collaborate with other projects. So yeah, don't neglect the documentation. This is a very important aspect of coding. The second file we can take a look at is the package.json. Package.json is a file that is used by Node.js to manage dependencies, scripts, and any sorts of metadata. So the first section of this file contains the metadata. So it contains the name of the project, the version, description, and a few keywords. Usually you will not need to deal with this part of package.json, except if you are writing a package on your own. Then you have the script part. So the script part can be used for any command that can be run with npm run. So I can show you, for example, if we do npm run start, we are going to run this script. This is useful for like building a project, deploying it, running some tests. But I think for the Motoko side, you don't really need that at the moment. Then you have the dependencies. So those are packages that will go into Node modules. You don't need to go inside the Node modules folders. It's very huge and very complex. So try to not dive into it. But basically all the dependencies that you have and also all the developer dependencies will go inside Node modules. And those are all packages written by other people that you can use for your own project. And whenever you run npm install, this is going to install locally, so the Node module, all the files that are listed as dependencies. The difference between developer dependencies and simply dependencies is that basically the developer dependencies are only needed during development, while the other dependencies are needed during development and during production. Okay, now I'm looking into package log.json. So package log.json, you really don't need to modify at any point. It's very much related to package.json because it's actually a file that is generated when you run npm install, and it installs all the packages that you need that are listed as dependencies here. And when it does that, it's also going to list the exact version number that is downloaded and used for your project. It's important because if you have many people working in one project, we don't want people to use like different versions of each dependencies. So this is the way that you can look at what is the exact version that I need to download. The next file we can take a look at is webpack.config.js. I remember that when I started my journey, it was the most confusing file. I had no idea how to read it and no idea how to modify it. So webpack.config.js is a configuration file for Webpack, as the name suggests. And what is Webpack? Webpack is a bundler. This is something that is used for front-end development, usually front-end development at very high level. So this is like a very simple project, but when you go to more advanced project, you will have hundreds of files and you will use tools like React, Tailwind CSS, Svelte, and all those complex tools require something to bundle all the files that you have into one JavaScript file that is optimized for the browser. This is what the user is going to load, and this is useful for like improving performances and using all sorts of features. So don't worry too much about this file for the moment. There will be a time in your career where you will need to modify it and maybe use another type of bundler. You also have Vite. But yeah, don't worry too much about Webpack for now. Just know that it's kind of a glue that takes all your file for front-end development and put all of them together into one simple output, which is called the bundle. Now let's take a look at .gitignore. So .gitignore is pretty straightforward. It's a file that is used to specify to Git which files should be ignored by Git. So all the files that are listed here will not be taken into account by Git. If you don't know what is Git, I strongly recommend you take 1 hour to watch a video about it and understand how it can be used to track code and publish your code on GitHub. But yeah, basically this file will just track the files that will not be published online. So for example, here we know that source/declaration, which is not here yet, but will be there, will not be pushed online. We know that node module will not be pushed online, and all other type of files. All right, so this is time to look at a file that is specific to internet computer development. This file is called dfx.json, and it's a configuration file for dfx. So dfx is the tool that we use to deploy and manage canisters. If you don't know what is JSON, I strongly recommend to pause this video and go watch a video like 10 or 15 minutes about about JSON, because this is very important and this is something you will encounter a lot. Our dfx.json has different sections, but the most important section is the canisters section. This section, which starts here and ends here in this case, lists all the canisters. So we have 2 canisters in our project, but you can have more and you can have less, of course. So let's start with the first canister. As you can see, the 2 canisters are separated by a comma. We have the first one here and the second one here. And then there is another section which is specific to each canister and lists a few more options. So for the backend, we have the name of the canister, first project backend, and then it's a canister of type Motoko. And a canister of type Motoko, you also need to specify the main file, which is in our case located into source first project backend main.mo. The main file is the entry point for the Motoko compiler. Then we have the second canister, which is called first project frontend, and is a bit more involved. This canister is a canister of type asset, and the asset canister is a specific canister that is actually loaded with dfx. You don't need to write the code for it. You just need to write the code that will be actually loaded inside this asset canister. So the asset canister is used to like store images, JavaScript files, and all sorts of other assets. So that's why we need to specify that this canister is of type assets, and then we need to specify what are the files that are going to be uploaded. And the files that are going to be uploaded are the one inside source, assets, and all those files. And also the files that are going to be in the this folder. And the this folder was created by Webpack. So remember I talked about a bundle. This is what is going to be uploaded inside the asset canister. Then we also need to specify an entry point for our application. So in this case, it's the entry point which is here, source first project frontend index.html. And then we also need to specify, but this is optional, a dependency. And the dependency is actually a canister that will be installed whenever our frontend is deployed. So if you think about it, the backend can live without the frontend, but the frontend would be broken if there was no backend, because you would, in our case, you would enter the name, click on OK, and it will just output an error. So that's why the frontend has listed the backend as a dependency. Then we also have more options, more sections. So this section is actually a section that is used for the build process. You can specify arguments that will be used during the build process. And you can also specify a tool for your packages. So you can use tools like Vessels, which we'll see later, is a Motoko package manager. And then we have 2 last sections. The first one is the version. The version is always 1, at least for now. This is the version of dfx.json. And then you also have output and file, which will locate your environment variable file. We don't need that, at least for now. All right, so now we can take a look at the source folder. And so we have 2 canisters, as I've said before, the backend and the frontend. And let's take a quick look at the frontend. So we have the source folder with index.javascript, index.html. So this is where we see that we have a button, we have a form where we can enter our name, and we have the logo here. The JavaScript file is able to perform actions on the website. So for example, here we will click on the button and then it will send a message to the backend canister. So we can see here, we can see here that we are calling the backend with the grid function with the name argument, which is the name that we will put inside the box. All right. And then we also have some assets. So those assets will be uploaded inside the asset canister. We have an image, we have an icon, we have some text and other types of assets. All right, so now we are at the Motoko part. For the backend, we only have one file, which is called main.mo. And usually Motoko canisters can have multiple files, but there is always one main.mo per canister. So other files will be like modules and helper functions, but there is always one main.mo per canister, and this is the file where you will see the actor section with the brackets, and inside you will see a list of all public functions for this canister. In our case, we only have one public function, and it's also a query function. This function is called grid. It takes an argument, which is called name, and this argument is of type text. Oops. And it returns a value of type text, async text if we want to be precise, which is hello and the concatenation of the name. So this is used to concatenate text. Deploying a project is a 3-step process. The first step is to create a canister. This will create an empty canister and will reserve an ID for it. The second step is to create the WebAssembly module, and to do that, we need to build the code. So we take the Motoko code, we compile it, and we create the WebAssembly module. And the last step is to install this module inside the canister. And this is the deployment process. Okay, let's deploy your project. So we want to avoid paying for cycles, so we don't want to deploy on the mainnet. And to do that, we will start a local replica. I recommend to use the clean flag because it will delete the .dfx folder if you have one. This is a folder that contains past replica and past deployments. So it's better to start from a fresh setup. Okay, so we are running 0.14 and we need another terminal because this one is going to be used for the replica. So now we can run dfx canister create, and we need to add the all flag because we want to deploy, we want to create the backend and the frontend. So this is creating a wallet canister. This wallet canister is going to be used to deploy other canisters. And we are creating 2 canisters. The first ID is this one, and the second ID is this one. Okay, now we want to build the code, and for that we run dfx build. This is building the WebAssembly module for the canisters. And actually, now we can see that we have a new folder which is called declarations. So let's look into it. We can start with the backend and with the .did file. So the .did format is used for a candid file, and candid is an interface description language. So it means it's a language that is used for describing an interface, and in our case, it's used for describing the backend interface. We can see that the backend is a service which contains only one method called grid, which takes a text and returns a text, and also it's a query. So Candid is a language that is specific to the internet computer. It was actually created and developed for the specific purpose of the internet computer. There are a few reasons for that, but that's not the subject of today. So the 2 other did files are actually just a representation of this file into other languages. So for example, this one is a representation of our interface in JavaScript. This is a bit complex. You don't need really to dive too much into it, at least for now. And then we have also the .declaration.ts, which is basically a way to get the type of our interface in TypeScript. So if you don't know TypeScript, it's a type language, and this is how we can get the type of our canister. You will see that we import packages from Definity repository, so Definity principal and Definity agent. Those are the packages that you see in Node module. Finally, we also have index.js. Index.js is pretty important because it's actually where all the code is written, so that you can, at the end of this file, you can import the backend. So the backend canister will have a representation as an actor inside the JavaScript code. So that way you can call your backend from the JavaScript code, which will be in the front end. And this is where you can import from this export the backend. Okay, so now we have actually built our code. So we have compiled our Motoko code and we have created a WASM module. If you are curious, you can actually go into .dfx folder, canisters, let's say backend, first project backend, and this is where you will find the WASM. So it's located here, and that's the module that is going to be installed on the internet computer. If you try to open it, so let's try to open it, you will see a lot of symbols because this is actually a binary file and your IDE is not equipped to read that. The way to solve that is to have the WebAssembly extension installed. So you can go to the extension marketplace, type WebAssembly, and it's the first one. So this one from the WebAssembly Foundation. Make sure you have this extension installed, and then go back to your code, click on the WASM module, and you can do something which is called save as WebAssembly text file, which is WAT. As you can see, the WAT format. And it's basically nothing more than just a copy of this module, but in a different representation, which is a type, which is textual representation. And this we can read. So this is still very much complex to understand, but at least you can see what's really inside the module. If you are curious to know more, there are different resources that I can point you to, but this is actually what's living on the internet computer. Okay, so now the last step that we want to do is to actually install this WASM module inside our canisters. So let's do dfx canister install, and then we can do /all. So it's creating a UI canister, which we will see later. It's the Candid canister. And then it's installing the code, uploading the assets into the asset canister. And that's it. We have our two canisters that are deployed on the mainnet. So now we can take a look at canister IDs.json, and we can see that we have three canisters. So this is, as I said, the Candid one, and then we have the backend and the frontend. So let's copy this ID. To access the frontend, you just need to write your local address, IP address. So this is the local IP address. This is the port that is used by the local replica. And then question mark canister ID equal, and then you put the canister ID of the frontend. So we can see the frontend, we can try it out, and it works. So the second thing I want to show you is that we also have this Candid UI. So let's try it out. Can replace the canister ID here. And now here we can take a look at the backend. So we take this ID, we put it here, and we go there, and now we can see the function of the backend, and we can also call it from here. So the Candid UI is necessary because it enables us to have a visual way of using the backend. If you just input the canister ID of the backend, so we can do it, you will not be able to access it because this canister doesn't have an HTTP request method. One last thing I want to show before turning off this video is that we can actually add more methods inside the backend canister. So let's say we have a variable of type text, which is called message, and it will store hello. And instead of passing an argument, we will just, let's say, return the message. And now we have another function, which is called public function change grid new message, and it will basically change the variable to be the new message. And we don't need to return anything, so we can just do something like this. All right. Now we can deploy that. And to do that, we can just run the command dfx deploy, or we can also do dfx canister dfx build. So it's going to build a new module. And then we can do dfx canister install. So we want to change only the backend. So first project backend, and we can say mode upgrade, and it's gonna upgrade the canister. Okay, let's take a look at the Candid UI. We can see that we have the two methods now. So if we greet, it's gonna say hello, and maybe we want to change that. All right, now we can check greet, and this is hola. So notice the difference of speed between the two messages. This one is an update call, so it takes around 2 seconds to perform. This one is a query call, and it's answered very, very fast, usually immediately. Now, if we want to add the last function, so let's say public query function greet2, and we will just do like this. So if we do that and we do build again and we upgrade again, we will notice that the state of the canister is reinitialized. So we set the message to hola, but if we go there, we refresh and we check greet, we can see that it's hello. This is because the state of the canister is never kept during upgrades, except if you have stable memory, which we will dive into on day 4. But for now, just assume that everything will be reset to the initial state. All right. So yeah, there was a lot of things in this video. Let's do a quick recap of what we've seen. And I'm also going to do live coding. So if you have questions, use the Q&A feature. I've already seen a few of them. I think it was, yeah, this is the code. So I'm gonna go back into it. Is it zoom enough? Maybe just a bit less. Okay. So there was there was a first question. Yeah, I should be sharing my screen. So I'm back. It's the exact same code that we had. So I am inside the Motoko file. Okay, first question. What is the question exactly was, so Candid allows Motoko to communicate with other languages. Yeah. So what is Candid? So Candid, you don't need to write in Candid, but it's still important to understand what is Candid. And this is what you see here. So in the declaration here, this dot .did. .did is a Candid file. And Candid is a language that was invented for the internet computer. It's basically a representation of the interface of the canister. So let's check our Motoko code. We have two methods. So the first one is greet, and the second one is change message. And that's exactly what we can see on the did file. You will notice that did, so Candid and Motoko are very close. Like for example, the text, the type text in Motoko is the type text in Candid, but without the capital letter. So it's very close. And also for like other types, you will notice that those are very close. This is because Motoko and Candid were developed at the same time for when the internet computer was being built. But yeah, don't stress out about Candid. It's only something to understand, but not something to write. And the goal of Candid is to be like a universal language for the internet computer. So you have all those canisters that will run, and they need to be able to communicate with each other. And some of them are going to be written in Motoko, but some of them are also going to be written in Rust, and some of them are even going to be written in other languages. And we need kind of a universal language so that those canisters can communicate with each other. And this is what we need Candid, why we need Candid, and it's also what you see in the Candid UI. It's basically enabling you to call any canister with a visual interface. So I'm going to show it again, the Candid UI. Okay, we have a lot of questions. So what's the difference? Next question, what is the difference between DFX deploy and DFX build? So DFX deploy and dfx build. Yeah. So dfx deploy is basically everything in one command. dfx deploy will create the canister, compile the code, and install the module on the network. dfx build is only the compiling part. So either you do dfx canister create, so you create the canister, then dfx build, you compile the code, and then dfx canister install, you install the module, or you can just do dfx deploy, and it's gonna basically do all the steps for you. I wanted to show the like 3-step process because I think it's important to understand like what's happening, but most of the time you can just use dfx deploy, and if you just it's gonna work and just do all the steps for you. Should we implement front-end for each project? No, for each project, it's only Motoko, and you don't need to have a front-end. If you want, it's gonna be good, very good thing if you want to have a front-end, but for those of you that don't know JavaScript, don't worry, you just need to write Motoko. Do we need internet to program in Motoko? No, you can do local development. So you can start, as I said, the local replica, dfx start clean, or just dfx start. This is, it's starting, as you can see, a replica. We can actually see it if we go there. Let me show you. I click on this address, and now I can see this. So it's not very very friendly and very nice, but this is a dashboard for the replica living on our computer. We can see that we have a version, and we have some information. And this is where you can deploy canister and you can kind of play. So it's a copy of the internet computer running on your machine. And you can deploy. If you don't have internet, you can deploy with the local replica. For the bootcamp, you need to deploy on the IC because when you will do the verification with the platform, I need the canister ID of the mainnet, because if it's local, the platform will not be able to verify your submission. So you can do most of your tests locally, but then when you need to pass, you need to actually go and deploy on the mainnet. And so one very important thing, when you deploy on the mainnet, you're going to pay. So you can actually use the same canister every time. I think I'm going to explain that very clearly in the first mentorship session, but you want to save cycles. Every time you create a new canister, is going to take, it's around 1 trillion cycle. So it represents, like, I would say 20, I think $1, something like this. So make sure that you use for each day the same canister, because once you have deployed day 1 and then day 2, you can actually reuse the same canister. But yeah, once again, I'm going to explain that later. We can say that Candid is the package manager. Not exactly. Candid is more like, if you're familiar with JSON, it's like kind of a language that you use to describe something. It's not a package manager. A package manager is more a tool than a language. Package manager, there are package manager for Motoko. I'm going to mention that, but it's later in the week. Okay, next question. So, but are you able to see the questions, by the way? Because I hope that everyone knows what I'm, yeah, okay, answering. So the next question is, for the day 1 project, we need to deploy it on the mainnet. For the day 1, okay, yeah. So you need to deploy it on the mainnet when you want to submit your project. But before that, you can actually deploy locally. Like if you just want to try and make trials, make errors, you can do that on the mainnet. But whenever you want to like pass on the platform, you actually need to deploy on the mainnet, take the canister ID, and input that on the dashboard. You can do with dfx new, but I recommend to start from 0 because that's actually very much clearer, I would say. You will see that you actually just need main.mo and dfx.json. You don't need all those front-end files and bundle and package.json. You don't need that to complete the day one. So I'm going to show like a setup to start the day one project. Why are there no wallets like MetaMask in the workflow? What do you mean by workflow exactly? I'm not sure. I need more. If you're talking about this project, then it's because you don't need one. Yeah, but of course there are wallets that you can use on the IC as well. How can we use React if we build? Yeah, there are templates for React projects. Probably I'm going to add those templates inside the links section. I'm gonna do that. Yeah, but I don't think you can. Well, actually, you can add it from this file, from this project. You need to go inside Webpack, and I think it's mentioned there. But yeah, I don't want to scare anyone here. I think it's here, but I don't want to scare anyone with this. I think we should focus on Motoko, and then I will answer later the questions on React. I have a Motoko dev Docker. Is there a way to force the port for the local replica to the ports? I'm not sure about this question actually, because I have not used a Motoko dev Docker. So I'm not sure. I think we should go through that later. Is a new canister for every project? So every project will be at, it depends. Like you can have a project. For example, there is an application on the internet computer, which is called OpenChat. It's a messaging application. So it's one project, but they have thousands of canisters, because even more than that, I think, because they have one canister per user. And so they have a lot of canisters, but it's still one project overall. You can also have a project with only one canister. For example, the dashboards that you see, it's one canister. So totally depends. For the bootcamp, all the projects have one canister. But in reality, most projects have multiple canisters. It depends on like what you want to do and the architecture that you're working on. The new deploy will delete the previous deploy. Yes, when you do deploy, there is a module inside the canister. So let's actually do something. So let's do deploy. So yeah, as you can see, the fx deploy, it will create the canister, compile the code, and deploy the WASM module. It's pretty good. Okay. So now we have the backend. This is the Candid UI. Yes, here. So we have we have those functions that we can use. Let's say we want to check. So we say hello, and now we want to change, and we want to change the message. So we say something different, hola. And now we query again. So as you can see, the variable that is here, message, has been changed to hola, and we query again. So this is hola. Now, if we do another deployment, so dfx deploy, I'm just gonna deploy first project backend, not the front end. So yeah, I'm actually changing a few things, but okay. And now we can refresh. If we greet, it's hello. As you can see, when you do a deploy, it replaces the module that is inside. So a canister, again, is a WebAssembly module. Whenever you deploy, you will replace the module with a new one. And whatever state is inside is going to be reinitialized. There is a way, of course, to keep the state and to keep the memory of the canister when you do an upgrade. But this is going to be something more advanced that we will talk on day 4. If I Google Motoko, it's bringing me to an anime. Yeah. So the anime is Ghost in the Shell. So it's a very, very good anime. And I think they choose this name. I mean, it's the main protagonist of the anime. And yeah, I think Ghost in the Shell is like kind of in the same spirit as the Internet Computer. And if you really want to know, I think you can ask Pocket Studio. This is the designer of Motoko, and I think it's him that chose this name. And actually, Motoko was called Actor Script before, but I think Motoko is more interesting. Major Kusanagi. Yeah, Motoko Kusanagi, yeah. Is Motoko an object-oriented programming language? Not really. Motoko is like Motoko is, I think it's not very much in one category or another. Like you have different categories of languages. I think it's more modern in the sense that you can use it for like oriented object programmation. You can totally like create classes, and you have all the features that you will need. But yeah, it's not like the main thing of Motoko. Could you write the steps for deploying locally a canister? Yeah. How much cycle the command, how much cycle I need. So locally, you don't need any cycle. Locally, the cycles are created for you. So I'm going to do it again, the fx start clean. Actually, I can do the fx stop. Then the fx start. We are starting the replica. So first command, the fx start. And then you can do like all the 3 commands that I've shown. So like it would be the fx create canister, the fx canister create, the fx build, and the fx canister install. But you can also just do the fx deploy like this. So it's 2 steps, the fx start and the fx deploy. Motoko is more of a functional language. Yeah, I would say. Yeah. Does the page check the code and tell me if it's okay? I'm not sure I understand this question. So is there a cost difference for deploy, install, or not really? When you deploy something, it doesn't really cost anything. I think it costs like it's a fraction of a cent. So you don't really see the cost of deploying. I've already done like hundreds of deployment on the same canister, and it doesn't like take cycles from you. The only thing that takes cycles, the main thing that takes cycles is creating new canisters. But once those canisters are created, you can redeploy as much as you want, and it's not gonna charge you for that. And no, there is no cost difference as far as I know between doing like the 3 steps process and the 1-step process, because under the hood, it's actually the fx deploy is actually doing all the things that you need to do. So I don't think it changed anything. The first canister you deployed actually cost you 2 trillion cycles. Yes, that's correct. Because there is a 1 trillion cycle is always the cost for like creating a canister. Like you can never change that. This is from the system. And then you can actually put cycles inside the canister, because you need cycles for paying for storage and computation on the network. So in the 2 trillion, you have 1 trillion for the canister, creating it, and then 1 trillion for charging the canister so that it can actually function on the network. I don't know why I can see the identity I use to do the challenge. Does the fx key in the data? Not sure. I cannot answer that without more like information. Maybe we'll go through that on Discord. Is it possible to integrate JavaScript framework like React or Vue to Motoko? So not to Motoko directly, but if you have a canister backend in Motoko, you can completely have a front end, and the front end You can have React, you can have Vue, Angular, Svelte, just HTML and JavaScript, whatever you want. That's totally like nothing really different from traditional web development. There are a few things like very advanced that are different because of the canister model, but otherwise most frameworks are going to work. Can we use the canister from the enrollment? Yes, you can use it totally. Like, I don't need this canister anymore. How can I catch my identity passphrase so that I don't have to input it every time I want to run? I think if you have like, you can create an identity without encryption so that you don't need to write the password every time. But if you have already created it, I'm afraid that you have to put the password every time. I'm not sure, like, I'm not 100% sure if there is like a better method, if someone knows, but I think if it's when you create the identity, you have the choice, but once it's done, you always have to input the password. How do you stop the local canister? Yeah, this is pretty advanced question, but you can actually do so. Let's say I don't know anything about DFX, so I would do something like DFX canister and then -- help to see what's actually possible to do on a canister. So as you can see, it's listing a lot of commands. So we have delete, we can delete a canister, we can call the canister, we can install, we can get information, and we can stop a currently running canister. So let's try it out. The FX canister stop, and then so we can go here. For those of you that are not very familiar with like the terminal, when you do those help flag, then you can actually see if you go up, you can see the syntax. So dfx canister option and then subcommand. So the subcommand would be dfx canister stop. And then to see what you need to input, you can do another help flag. Now I go up, dfx canister stop, and then I need to put options if I want and a canister. Specify the name of the canister to stop. So I'm just gonna do that. dfx canister stop. It's called first project backend. Again, if you want the name of the canister, just go to your dfx.json. This is here. This is my backend. This is the name, and this is the name of the frontend. So yeah, let's go back to the terminal. Okay, oops. Happened exactly. Okay, so dfx canister stop first project. Let's try it out. And we actually stop the canister. So now we can check. Actually, the call has failed. Rejected. Canister is stop. And when a canister is stop, you cannot call it. This is something that you will actually very rarely do. Like, there are a few edge cases where you want to do that, but otherwise it's not something you want to do on a daily basis, I would say. And you can start it again with dfx canister start. And now it works. But maybe your question was about stopping the replica. If you do dfx stop, it's going to stop the replica that is here. And when the replica is stopped, it's going to remove all the canisters from it. Yeah, I'm going to provide the code for this lecture. I don't think I will be able to answer all the questions. So I think we have a few people that raised the hand. Let's see. They want to talk. So Luis, you can talk now. Luis Wilka, if you are here. Okay, so maybe Mio. Mio, you can talk. Okay, I'm gonna try one more time with Julian. Julian De, I cannot read the full name. De Bonder.
Can you hear me?
Yeah, I can hear you.
Yes, I wrote a question in the chat. I asked if do we will need to bring the actions from the backend and attach those actions to the front end with function events?
No. So
Ah,
I wanted to show it. I mean, not for this week. You can do it if you want, but I wanted to show you like how a real project works. So like when you have a front end and a back end, but for the bootcamp, you only need to code the backends. So for example, for the day one, let's go to Motoko starter. Going to zoom. So let's say, so the day one project is this calculator project. You need to do all of this, and then you need to have those functions. But you actually, you just need to write the main.mo for it and deploy that, and then you're good. You don't need to have the JavaScript part and all of this. All right? Does it answer the question?
yes. So for the day one, we only need one file.
Yeah,
Sort of.
exactly.
Right. Thanks.
Actually, you already have the, if you go here, you have the main.mo with the files already, like the functions. You just need to write the code for it. And you will find like the instructions and in the chapters and the resource for like how you implement addition and subtraction and so on.
Right. Thanks.
Okay, I'm going to stop here 5 minutes before the end of the hour because I want to verify that the networking session we have just after will work. I know you might have a lot of questions, so just go to the networking session. Let's have a few minutes of relaxation and get to know each other a bit more. And then I will spend more time on Discord and you can ask me any question and I will try to answer all of them. Thanks everyone for joining and see you at the networking session. Bye.